Hi, I'm Guang, I'm 50 years old. In this lesson on the limit calculation, we'll continue to look at these types of questions. So this type of question, what exactly it does is that it gives you some kind of function. It gives you the result of its limit. But there are some coefficients or constants that they will need you to determine. And in our case, what we're given is limit x approaches to 1. ax squared plus bx plus 1 over x minus 1 is equal to 3. And we're supposed to find the values of a and b. Alright, so that is what we have in this lesson. And what we are going to do is to use 3 different methods to solve it. Alright, so let's start with the first example. Or the first method, I should say. So, method 1. So what will our first method be? Now, of course, one of the more obvious ways is to directly use factorization if you have not really learned any other special methods to solve limits. So, factorization. Now, how are we going to factorize whatever we have up here? Since we do have limit x approaches to 1, ax squared plus bx plus 1 over x minus 1. So how about we change the ax squared into ax multiplied by x minus 1. But since now you have an extra minus ax, you have to add back that ax. We can combine with the next term to form a plus bx. Right, so this is what you are going to see. Now, from here, you can use partial fractions to remove your first term from the fraction already. And then for your second term, you're just going to repeat the same process, where you're going to have limit x approaches to 1. Then you're going to see ax, and you have to add a plus b. Then it becomes x minus 1. So a plus b multiplied by x minus 1, you have subtracted an extra a plus b. So you have to add back that a plus b. Alright, so this is essentially what you will see. And next, once again, you can remove the two partial fractions in order to get limit x approaches to 1, and you're going to see ax plus a plus b plus 1 plus a plus b divided by x minus 1. Okay, so this is what you will see. And this will be equal to 3. Now that we have reached this step, what can we continue with? Now there will be a few different ways to look into how we can solve this part specifically. Since you look at the last term, you have something over, if you sub in the x, there will be a 0. But since this is a 3 not infinity, which means one of the things you can derive is actually 1 plus a plus b is equal to 0. And while the other thing you can get is, since you have ax plus a plus b, and if you substitute in your x, you're going to have 2a plus b. This is equal to 3. Alright, so now you just have to solve these two simultaneous equations. So in order to solve them, you can realize that a plus b is equal to -1. They use the second equation to subtract the first equation to get a is equal to 3 minus -1. Well, then you will get a is equal to 4. They will put a into your second equation or the first equation. And then you'll get b is equal to -5. Alright, so there you have it with the first method of factorization in order to get this set of simultaneous equations to solve that a is equal to 4, b is equal to -5. Now we'll take a look at our second method. So, method 2, actually once again it will be a factorization. So you can also choose to differentiate these two methods with like factorization 1 or factorization 2, but whatever. So what's so special about this factorization and the previous factorization? So the previous factorization is a more generic version, but in this method of factorization, you already know that original limits you're given. You have something over x minus 1. So in order to get a constant 3, which means there has to be something that can be simplified from the numerator to cancel out with this x minus 1 in the denominator, which means there will be x minus 1 in the numerator. And for the rest, how you can determine it is you can have ax multiplied by x to get your ax square. And well, for the other part, it depends on what kind of way you want to use. But otherwise, you can also take a look at the very last term. So in the very last term where you have add 1, you can either choose to have a c or it's just -1. Alright? So this is how you can choose to factorize your original limit here. Now, what will be so special about this kind of method? So in this kind of method, what happens is actually something that you'll find very mysterious, you could say. So since this part is equal to 3, now if we just look at the parts behind and we choose to simplify the two x minus 1s. So what you will find is after you substitute in your x is equal to 1, you'll find that a minus 1 is actually equal to 3. Well, from here you can get a is equal to 4. And what happens to your b? So your b would actually be -x minus ax. So, well, x is just 1 after all. So you might just already can tell that you have a -1 minus 4. Since this is from your a, or you can also choose to leave this as -a, but whatever, is up to you. So then you get a -5. So a is 4, b is -5, and this is the same as your previous method, but just in a different way to factorize your original function here. Alright, so now we'll take a look at the final method, method 3. Well, in this method, we will be using the L'Hopital's rule. So the L'Hopital's rule, it is essentially just differentiate both numerator and denominator. And in this case, since it is a 0 over 0, because you can actually solve it, and the denominator, if you just substitute x in, there will just be a 0. So there's definitely a 0 over 0 form here. Now, that also means we will be able to use a L'Hopital's rule. And thus, using a L'Hopital's rule, we will have limit x approaches to 1, and you have 2a x plus b divided by 1. Since x minus 1 you differentiate, it's just 1. And this is equal to 3. And from here, you get another set of simultaneous equations. Since now you can just substitute x in to get 2a plus b is equal to 3. But where do you get your other simultaneous equation? Now, since this here is a 0 over 0, or supposed to be a 0 over 0, which means if you just substitute x in for a numerator, that will be a 0. So substituting x in for your numerator, you're going to have a plus b plus 1 will be equal to 0, but since you can also at the same time move the 1 to the other side, so a plus b is equal to negative 1. And now with this set of simultaneous equations, you can just use equation 1 minus equation 2 to get a is equal to 4, and then using a sub into equation 2 to get b is equal to negative 5. Alright, so once again we have solved for this a and b, this limit that a is 4 and b is negative 5, where you see that this answer is constant throughout our three methods. Alright, so let's take a recap of what kind of methods we have just used. So method 1, your factorization, where you took whatever numerator you have, trying to make some kind of x minus 1 term up there, and keep taking them out of the fraction, which is also partial fractions. So technically method 1, you could call it factorization and partial fractions. So you have factorization and partial fractions, then just repeat the process until you get something that looks like this. And with that, you can then determine that the numerator of your fraction is actually a 0, so that the entire thing just doesn't become infinity. Well, the previous part, or that will just be whatever answer you're given, which in this case it is 3. So afterwards you solve the simultaneous equations, you get whatever you need, which is your a and b. And next, for your factorization, which in this case it is a different kind of factorization. Well, you kind of have the mentality that you already know that there's something you take from within the numerator, and in this case there will be an x minus 1. So that's kind of the simplification that you need in order to solve limits. So it is kind of like completing, but then there are also other ways to describe it. So after you manage to take out the x minus 1, and by just taking a look at your first term and your last term, which is respectively the term with x squared and the constant term, with that you can pretty much determine whatever your b is, and of course not before you find out the a by just simplifying and substituting x in. Alright, so that will be for the second method in order to find a and b. Well, for a third method, well, you just use the L'Hopital's rule. L'Hopital's rule differentiate both numerator and denominator. You get this form. Substitute x in, you get one equation, and from your original part, you can substitute x into the numerator, and since it has to be a 0, then that is where you get your second equation, and that's how you form your set of simultaneous equations in order to solve for a and b, which are respectively 4 and negative 5. So I hope in this lesson you're clear of these three different methods so far. I will be ending this lesson here, and thank you for your watching.